All right, so exponent laws. So in this video, it's a continuation, and I'm assuming that you have watched the introduction to exponents. So I will do the link up on top so that you can take a glance. If you've watched it, great. Now, these exponent laws, when you're just starting and you're kind of looking at the screen at the moment, it probably will be a little bit overwhelming. Now, for teachers teaching it, because we have done it for so long, these things just kind of create these models in our head that we can very quickly be able to spot it. But for students, it's very difficult. So I certainly do feel you when you're starting off with these exponent laws and trying to remember what initially do you have to actually do to make these things kind of stick. Now, the only trick really is to try to do as many questions as you possibly can and not just watch a video or maybe read a book or something of that nature. If somebody else is doing it, then it does sometimes seem a little bit easier, and then you seem like, oh, okay, I understand. Remember, it's not until you try to explain those concepts to somebody else and you try to actually tackle real questions that you really can tell and see what you understand, what you don't. So let's break these down, okay, kind of one by one. And before I do break it down, I do want to make sure that, we're assuming that in this case, this number A that I have and you see everywhere, I'm going to assume that it is not equal to 0. So I'm going to kind of leave off the zeros for the moment. And then I'm also going to assume, because we have a B, that B is also not equal to 0. So these are just two numbers. So the number A and the number B you can think of as a number, and I will use numbers to show you these rules. And when they're not equal to 0, we can kind of create these nice laws that we have. With those technicalities with a 0, okay, we'll try not to worry at the moment. So let's take these, okay, and then the first ones that I'll kind of glance at is these two, and then I'm going to keep coming back to try to illustrate these to you in general. Now, if you've watched the introduction to the exponents, then you kind of know what a zero exponent does, and you know what a negative, okay, exponent does. So in this case, you may remember that a number raised to the power of 0 is just 1. So because I've explained this now a couple times in the videos, okay, in the introduction, so I'm not going to explain that again. Again, remember, A is not equal to 0, so it can be any number, positive, negative, decimal, whatever it may be, but it's just not equal to 0. So any number raised to the 0 is just equal to 1. So that's one of the laws that we kind of remember, okay, and I showed how to do that. So I'm not going to discuss it here, and maybe I'll do another link up above to when those exponents are 0. Now, what happens when the exponent is a negative number? So here, for that, okay, so I am assuming, so n, okay, so it is some number, and we're making it negative, okay, because of the negative symbol that we have in there, okay, so right there. So what happens? Now, negative exponents actually typically mean division. Now, in general, when you have negative exponents, you can very nicely capture them by this particular law of just 1 divided by, again, this comes from the division, and a to the n. So this is what happens. Now, I do want to give you a little note on this because, okay, so from here, it also follows. Okay, so sometimes you will see this and, you have to kind of become accustomed to this and try to see how these things kind of flow. So when you have a number, so any number, okay, so for instance, if I have the number 3 and I raise it to the negative 4, okay, so now my A is equal to 3 and my N is 4. Notice the negative. So what this really means is 1 divided by, okay, so 3 to the power of 4. And as you may recall, so negative 4 just simply means you're dividing by 3 4 times. Now, what would have happened if we would have had, okay, so let's say in reverse, and we would have had this -4 kind of at the denominator. So what happens in this case is because, okay, so notice that this right here, so when we have that, okay, so this particular item at the bottom, we know that that is 1/3/4. So from your fraction, so basically what this is, so this is 1, and then this becomes 1/3/4. And when you rewrite this, okay, so because this is just in fractional form, okay, then this turns out that my 3 of -4, which we had at the bottom, okay, pops up to the top. Okay, and that comes out from right here. Now, this is something that you should remember. So therefore, we can write, okay, or we can add that if we have 1/a to the -n, it actually equals to a to the n. Okay, and that's exactly what has happened right here. So these two things go hand in hand, and sometimes you do see it, and because we like to work with positive exponents instead of negative exponents, you know, we very often can kind of shift them. So notice that they'll just go on the opposite side, so either in the numerator or denominator, depending where the negative lies. All right, so that's the first kind of two laws. A to the 0 is equal to 1, and then a to the -n is equal to 1/a to the n, where the negative disappears. All right, so those are the two items that we have. And I will create a video on just pure out examples so that you can practice as well. Okay, and then I'll do that a little bit later. Okay, so now those are my first two exponent laws. So these two right here. Now let's move over and we'll shift over to the next laws of multiplication and then division with exponents. So let me bring this down here. So this is what I have. Now let's try to explain these. So I'm going to first concentrate on this one. And I'm going to just show it to you with regular numbers so that you can see what we mean. And the only thing that I wanted to point out is that when we have a multiplication between two different, okay, in this case, basically factors that we have, so a to the n and a to the m, we do not need to write that multiplication. It is actually understood that that multiplication happens. So very often you're not going to see a multiplication, and all you're going to see is written it in this particular format. And the same thing happens with division. When you have division, very often we write the division between different factors with exponents just simply by the fractional division symbol. So those exactly mean the same thing. So here are some examples, and I'm going to first illustrate the multiplication. So let's take a number, it doesn't matter what number, it can be your favorite number. So let's say a is equal to 5. All right, so what we have is 5 to the 3, and then it is being multiplied by, let's say, 5 to the 2. Those are arbitrarily, okay? So I've chosen all of these things arbitrarily, but here it just hopefully shows you what this means. Now, in that introduction to exponents, you know that 5 to the 3, so what that actually means, so this right here, is actually just equal to 5 multiplied by 5 multiplied by 5. So that's what that means. Now, 5 to the 2, on the other hand, so this right here, so I'm going to rewrite that, that is just equal to 5 multiplied by 5, okay, so 2 times. So what do you notice? You notice that really what we have is we have a multiplication, so 1, 2, 3 by 5, and again, we're still multiplying by 5 another 2 times. So what this results in is 5 to the 5, because we have 5 multiplied by itself 5 times. And what that will tell us is that the actual rule, what we do is when you have the same base, so this is A, which is the same base, so that's what happens there, then all you have to do is you have to just simply add your exponents. So notice 3 plus 2, which is going to be equal to 5. So your rule that you have, so right here, when you're going to have the same base, so with some number, then all it is just simply adding up your exponents. Now your exponents can be both positive or negative, all right? And again, so seeing more examples, and I will throw some more examples and even create probably a worksheet, okay, in a separate video which will follow this one. So that's what you have, okay, for this particular law. So whenever you have the same base and the exponents, okay, all you do to them is just simply add them. Now, on the other hand is what happens when we have, okay, so division. So when we're running into this problem right here. So with division, so let me paste it down. So what happens when we have division? So again, let me illustrate this by example. So imagine that we have, and I'll take different numbers, let's say 10, okay, and now I'll put it, okay, to the 5 right here, and then we are dividing it, so dividing that. So again, the base is the same, so in this case my A, okay, is 10, and let's say I have a 2 right there. So that's what I have. Now I can rewrite this, of course, just by saying 10 to the 5 divided by this fractional division, 10 to the 2. And notice here what, again, this means. This simply means I have 10 multiplied by 10, in this case 5 times. So I'm going to write that in. That's 4, 5, and here, okay, at the bottom, I have 10 multiplied by 10. So this right here, okay, is represented by the numerator on top, and then this right here, okay, is represented by the denominator at the bottom. So that's what we have. And you can now clearly see, okay, so notice what happens if we simplify this. Well, since we have the same base of 10, so really 10 divided by this 10 is just equal to 1, so that would cancel. And then 10 divided by this 10, again, is just equal to 1, so it would cancel. And all you have left is these 3 10s left over. So my answer overall really is just 10 to the 3. Now, when you do that, again, you can spot a pattern that you will notice that when you are dividing with the same base, what you can do is the exponents will simply subtract. So I could have just written this out, if you know the law, that this is just 5 minus 2, which is equal to 10 to the 3. Again, the base has to be the same. All right, and what I mean by the base being the same, please don't get fooled. If you have something like this, and then let's say something like that. In this case, it's not the same base because we have a 7 and an 11, so you can't just simply subtract the exponents. All right, so that's what I mean by having the same base. So this law right here, what it tells us is that we have, a n minus m. And that's what that particular law states. All right, so that's what we have there. Now, if I scroll back up here, okay, so you notice that basically this kind of summarizes these two laws right here. So it's a multiplication of exponents, okay, and then you have division. Now that leaves us this particular last item right here, okay, to try to see and understand. So let's break that one down as well with some examples to try to see this particular exponent laws. So let me paste this down, okay, and then what does it mean? Now these are actually very similar and very close. Once you understand hopefully the first one, you'll slowly understand the other ones as well. So let's take this one. What does this one mean? Okay, so what it means is, and again, I'm going to just throw in some numbers for us. Okay, so let's say that I have, then I'll make the number a little bigger. So 20, say to the 3. Okay, I'll put it in brackets. And then let's say I have this to the 2. Okay, so now you can see both of these. So let's say my A is 20. And my n is equal to 3, and then my m is equal to 2. So what does this mean? So first off, you obviously have to understand, okay, that when you have exponents, okay, what do they actually mean overall? So if I take, for instance, okay, so just the bracket on its own, so if I take this bracket and I apply this 2 right on top, then what this means is that I have 20, okay, because I'm applying the bracket, okay, multiplied by 20 to the 3, okay? So this is what I have. Why? Because, notice, it said that the exponent was 2, so I've applied it to the bracket 2 times. That's what that comes from. But wait a minute, now what you notice, so here, from right there, okay, so what you will notice is that, oh, okay, so now these brackets, okay, are kind of irrelevant. So what I have, okay, is the following. And, well, we know this because, okay, this is just the multiplication law. So we have the same base. So what do we do with these exponents? So you're probably thinking, so indeed, we just add them. Right? We just did this law. Okay, so that was one of the laws that we just covered. So therefore, okay, so this right here just equals 20, and then 3 plus 3, which is equal to 20 to the 6. So that's what that would mean. And if you take a look at this, okay, and try to deduce what actually happens, because we are just simply doing the following. All right, so let me kind of remove this right here, and you will notice that what happens in these examples, okay, is you don't have to go through all of this right here to try to find your answer. All you have to actually do is you can use the law, okay, and it just comes from the following. What I have just done is that our law tells us that what we're going to do is we're going to be multiplying the exponents if we have this in brackets. So we're basically distributing through into the bracket the exponent. So the law states, okay, so this first law right here, okay, what it states is that all you have to do when you have these particular brackets, you're going to be distributing these through, okay, and notice that it's multiplication. So it's not addition like we had in the previous law, but it's just simply multiplication. So in this example, what we would do, instead of going through all of the junk, we can just simply say the following, and that is equal 20 to the 6, and notice that's exactly what we got. But that's where it comes from, so you can visually kind of see what is happening. So this brings us to the next example, and you can probably guess. Now, very often once you start working with polynomials or monomials, and you run into these exponent laws, you're kind of going to have to try to understand them. So notice that in this second example right here, I've added kind of two things. We have a base of A, which we've already done in the previous one, but we have now another one. Now, what happens in this case? Now, it could actually be multiple things that you have. All right. So from the previous law, what we do is we just simply will multiply the exponents. Okay, so this gets distributed through across, and what this will be is a n multiplied by now this q, and b m multiplied by q. And that's what the law actually states. So it states, okay, that you can show this by examples like this. We can do the same thing, and you will notice that instead of doing all that work, we can just simply distribute through and simply multiply the exponents. That's what you would have. And this works for anything. So for example, if you would have, okay, so this is just a side example. If I have 2 to the 3, okay, so multiplied by, let's say, 5 to the even 8, and then multiplied by 4 to the 3 again, and let's say I have a 2 outside. What this means is that whenever we have these brackets like this, and we apply an exponent on the whole bracket, then we are just going to be distributing through every single exponent. So this is actually 2, and then this is 3 times 2. It's going to be 5. 8 times 2, it's going to be 4. 3 times 2. Then we can find what the answer is. So 3 times 2 is 6. 8 times 2 is 16. And again, 3 times 2 is 6. So that rule actually applies because of this. All right. Now, the last one, so let me, because it's a little bit cluttered, okay, so this one right here, so let me copy it. So this rule right here, just because it's division, it doesn't change anything. So just like the previous ones, what you would do is, because you have this exponent, what you're going to be doing is you're going to be distributing it through, okay, into those exponents. So what you have in this case is that the law says a n multiplied by q, and just because you're dividing, it doesn't really matter. This is b m multiplied by q. Okay, so that's the law. So in terms of an example, what you would have is, you would have, for instance, 3 to the 4 divided by 2 to the 3, and then let's say this is raised to the, and I'll put a 4 here as well. So what you have is now you're going to be distributing, so this 4 times 4, and then 4 times 3. So this is 3, 4 times 4, divided by 2, 3 times 4. All right, so my answer becomes, I can keep it in exponent form, so that's what it would be. Now, of course, we can get the full answer period because these are just numbers. But the key for you to remember is that we want to be able to know these particular laws. Oops. Let me maybe change the style. Okay, so that's the law that we would want to know. All right, so those are all the laws that you have. Now, if you understood all of this, great. I actually don't suspect that you would on the first go, but you may, if you maybe have seen something like this before. These particular exponent laws you're going to be running into quite often. All right, so here they are, okay, kind of in summary format, and those are the ones that you should slowly trickle them into your long-term memory if you want to stick around and learn a little bit of math. And they are relatively useful as you continue on in your math education. In the beginning, it's always difficult to try to see where this stuff is used. And I wish that it would have been easier. Okay, so sometimes it's a trick, and you kind of have to learn the laws as you go on, practice them enough, and then slowly you see them pop up. Because exponents do play a role. Okay, so for example, I teach business math courses, and I know that we use exponents quite a lot because of compounding. So if you ever get into investing of any kind. All right. Okay, so thank you for watching. I will do a video just purely on examples and applying these exponent laws to them so that you can practice as well. Okay, cheers. Bye.